I used to write in JavaScript, felt so free, but my code would break, oh, endlessly. Now I got TypeScript with types by my side, helping me catch errors before they collide. TypeScript variables, gotta keep them straight, with number, string, boolean, they're first rate. Infer or annotate, it's up to you. With TypeScript variables, there's so much you can do. I can use letter const, never var no more. Var brings trouble that I just ignore. With let and const, I know where they scope. Keeps my code so clean, like a tight wound rope. TypeScript variables, gotta keep them straight, with number, string, boolean, they're first rate. Infer or annotate, it's up to you. With TypeScript variables, there's so much you can do. Got my union types and literals too, combining types like a programmer's do. Unknown is safer, any is wild. TypeScript variables keep your code compiled. Arrays and tuples, enums and more. With TypeScript's power, I can truly explore. Type inference magic, but I annotate strong. Helps me code better, can't go wrong for long. TypeScript variables, gotta keep them straight, with number, string, boolean, they're first rate. Infer or annotate, it's up to you. With TypeScript variables, there's so much you can do. TypeScript variables, they save the day. Help me write code the professional way. From let to const to never and void. With TypeScript, my errors are easily destroyed.
All right, back in Visual Studio. So first let me say that in TypeScript you can still say this, let val equals 55, and it will infer what type that is. We actually sometimes will want to do that, but mostly we won't want to do that. Mostly we want to take advantage of TypeScript and let it know the type. Just in case down the road there's some ambiguity, TypeScript will make sure there is no ambiguity. And if we say console.log val, now if we try to run this with the Control F5 or whatever, I'm going to say Node.js, it doesn't work. Well, that's because TypeScript has to be compiled into JavaScript. So down here we're going to say TSC, that's TypeScript compiler, learn1.js, excuse me, TS. And so it goes ahead and compiles it. And lo and behold, learn1.js appears up here. And we can run it with Control F5. And we go to the debug console and it runs, okay? So that is really nice, but what happens is you get this error here because there's a val there and there's a val there, and it gets confused to which one you mean. So if you say export down at the bottom like that, and you recompile, well, that will not happen. In fact, you'll notice that you get some actually cool code that gets injected up here. Okay, so that's the very beginning of TypeScript and how to use it. So let's go ahead and do a string. Let's say let my name equals Rick Lineker. And that's how I would do it in JavaScript. But here, I want to give it a type and say string. so that we'll avoid any kind of ambiguities. Console log my name. Here again, this export is going to save us from getting that error that we got before. So we save this, go down here, compile it, and you can actually do this a couple of ways. You can go back here each time and hit Control F5 and run it. That's fine. And your debug console will show you what it outputs. Or you can actually, from the terminal, just say node learn1.js, and it'll show you that. And the last thing we're going to do real quick is a Boolean. Let my decision Boolean equals true. Console.log my decision. And so let's go ahead and do the same thing here. Compile it. Oops, sorry. Compile it, run it. All right, so these are the three major types we're going to be using. However, there are going to be quite a few other things we'll have to take into consideration. For instance, there's a type called Any, A-N-Y, and so we'll talk about that shortly. Some of you might not want to do a two-step process of compiling and then running. And that's okay. There's a way around that, which I don't recommend, but you can still do it. Down here, I'm going to install ts-node. I'll type npm install-g ts-node, and that will go ahead and install ts-node. I also have to install the types so that your programs can find stuff like console.log. So I'm going to say npm install space @types/node --save-dev, and it will install the types for me. Perfect. And you'll notice that you'll get something in your node modules up here, and you will get a package.json here. That's just going to let Node where to find those. So to use it, all I have to do is say ts-node learn1.ts. And this is convenient when you're doing simple things. However, it doesn't do the kind of type checking that the compiler is going to do. So I still recommend you do this two-step process of compiling and then running. You can do this if you want. I will do this many times for like really simple things, simple changes. But in general, I don't like it because here again we're opening ourselves up to errors, which is one of the reasons we're using TypeScript. Now we're going to talk about 4 other types. They're not as common as number, string, and Boolean, but they're still important. So let's say let random number, or say value, and we're going to make this an any type, equals hello. And what that means is this can be anything. So right now it's a string. We can say random value equals 42. Now it's a number. And you're going to say, why do we have to do this? Why don't we just do it the old JavaScript way and not have this any? And the reason is because when we do things, fancy things with functions, we need that. That's why. It's really easy for me to give you some sort of a blow-off answer, but you'll see later on when we talk about functions what I mean. The next type is a void, and a void is almost always going to be used with functions. Now, if you've written C code or C++ code or Java code, many functions or methods will return a void type. So that's exactly what happens, and obviously we haven't talked about TypeScript functions yet, but function, greet, and we put our return types up here. And this return type is going to be a void, really the same as if you had a C program or Java program or whatever. Console.log hello. And now you notice we're not returning anything because we don't need to, since this void says we're not going to return anything. Okay, So we also have a null. We had a null in JavaScript too. So we're going to say let empty null equals null. Okay. And I actually rarely use this, but occasionally it comes up. Let not assigned undefined equals undefined. Here again, I rarely use this expression. So these two expressions you're probably not going to see a lot. So I'd like to reiterate that TypeScript can also type infer, just like JavaScript did. So we can say let message equals hello TypeScript. Okay, and it knows that that's a string. We could also say let value equals 42. All right, the meaning of life, 42. We don't want to do that, that's the problem, but you can, and sometimes I do, especially when I'm really in a hurry and I just want to get something done. I actually should never admit that. But let's say you do have a variable, and it can be either one or the other type. You have a better option than just making it a straight type inference. You can actually tell TypeScript which two options are available. So for instance, identifier could be a number or a string. And that narrows it down from the entire realm of possibilities. And I can say identifier equals, this is a test. And then I can turn around and say identifier equals 101. So here I kind of have my cake and eat it. So in this case, I can have TypeScript keep things to two options, not like every type there is. And that actually is going to help me still keep things under control when I want to have a little bit more flexibility. There's another way you can have flexibility but still keep things, keep things managed. So let's say traffic light. And we're going to say what the traffic light can be. So now we have our three choices. And so it not only tells you that these are strings, but it also tells you what specific strings it can be. So you can say traffic light equals red. And notice it is case sensitive, so if I made everything a lowercase, it would have to match case. Another type is called unknown. This is a safer alternative to any, but you must narrow its type before using. Here is an example of that. I've declared this variable called some value as an unknown, and here I've told it what the type is. Now it can't be any other type, and I use the type of operator. I check to see it's a string, and then I go ahead and output it. And in this case, I output it as an uppercase. We also have an alias type, and what that does is it creates a new name for a type. I don't know if some of you have done any C programming, but in C programming it's fairly common to use a defined to rename, say, a struct or a function or whatever. So here's how we can do this. We say type ID equals number or string. Okay, so it can be either one. So now I have an ID as a number here, and I have an ID as a string. So it can be either one. This next one, in my mind, is pretty weird, and it only has to do with functions. And I know, here again, we haven't talked about functions yet, but this should be pretty easy to understand. What never says, never is a return type that says, we're never going to return. So if you never return, how do you get out of that function? Well, a lot of times it will be maybe something in a thread, or you can throw an exception, and that way you get out of it. But I think I've, in my whole life, have only used this like twice. So pretty much all languages have what we call enums. It just gives you the chance to give maybe numbers a meaning that you can actually read. You don't have to memorize numbers. So here we have directions, up, down, left, right. So instead of having maybe up as a 1, down as a 2, left as a 3, right as a 4, you don't have to memorize anything like that. You can just have these readable enums that you can use like this. So this is going to be a direction enum is the type, and then we just say that equals direction dot up. And I know that we've already talked about a number type, but you might need an array of numbers. And so you can say let numbers equals an array of numbers, okay? And here's your list of. Now note that 1, 2, 3, that's my array of numbers, okay? So remember that JavaScript lets you add different types into arrays, like you could add maybe a number and a string and a boolean into an array. But here it's specifically saying it's not going to let you do that. It's got to be a number here. And we have an idea of a tuple. Now, if you've ever programmed in the Haskell language, it's a very important type. So I say let person, and I have two types, a string and a number. Alice and 25, it could be Rick and 78, it could be Empire State Building and 14, it wouldn't matter. But you have to have a string and a number when you specify this tuple. So we've pretty much been using let through these examples, but you can also use const. So if you want to have a const of pi, number equals 3.14, you would do something like this. You are allowed to use var, but I definitely would not recommend it. Even if you type it, I definitely would recommend it. And the reason is because of the scoping issue. So here's a common error you might get. Let num, and you type it as a number, equals a string. That's going to give you a big fat error. So let me just leave you with a few thoughts and recommendations. Use type annotations to make your code more readable and maintainable. Prefer let and const over var. Use unknown instead of any whenever possible for better type safety. Use union and literal types to handle specific use cases.